Okay, so we have a sample, but you cannot analyze it directly. You need to do some sample preparation, maybe to concentrate, to separate your analyte, toxic compounds or drugs of abuse or something of interest from most of proteins, salts, all these messy metrics you have in a real world sample. So let's look what can we do with different type of compound. We'll start with, of course, the easiest way is when you have the sample in gas. You can collect it in a bag, you can collect it in canister. The very good idea is to collect it into cartridge uh, made of polyurethane foam or some resin, and then compounds of interest will be absorbed on this surface, and then you can analyze. You can run such filters through cubic meters of gas and have detectable concentrations of very small amounts. Now, when your volatile compound is in liquid or solid, you can do so-called headspace analysis. You're placing your sample in a headspace vial, something like this or this. It can be liquid, can be solid, and then slightly gently heat it so volatile compounds will go into gaseous phase, above liquid or above solid. After that, you insert the needle and take a sample of this gaseous phase into a syringe. This can be done automatically. This example of automatic headspace analyzer, a very common approach for many semi-volatile compounds. Partition coefficients of some common solvents between water and air. Cyclohexane, hexane, they do not stay in water. They prefer to be in air, so amount in water will be very small. Aromatic compounds are better staying in water. Even more ketones, ethers, esters, alcohols usually like water, like dissolves like they have hydroxy groups. Still, concentration of ethanol and dioxane will be high enough if you increase the temperature of your aqueous solution. There is another approach of headspace analysis, which was designed around 80 years ago by Conway in Ireland, so-called Conway cells. Or what is it? You have two spaces. One in center is your receiving area, and then there is circle here. You can put your source sample. So in this area, you are putting your very dirty samples, say blood sample or urine sample, or with no purification, and adding some salting out agents. Salts will force volatile compounds out of your aqueous solution. In the center, you are putting or pure water or some suitable receiving phase or simply indicator like here. So volatile compound is coming from this area into this area and react with reagent you want. Alternatively, you collect this phase and analyze it by any means. What can you do with this? Any volatile compounds, for example, hydrogen cyanide will go from blood into testing area and change color of indicator. Ammonia, hydrogen chloride, all halogenides, chlorine, bromine, iodine, alcohols, acetone, and lower ketones, aldehydes. All of them can produce volatile compounds, can be easily detected. Carbon monoxide, another example. Very simple, very inexpensive, very reliable procedure. Another more sophisticated way, specifically for gas chromatography, is to put a microdrop, say 1 millimeter radius, at the end of the needle in a headspace. So alcohol doesn't want to stay in air, as you have seen, but it will be forced from starting source phase into the droplet by addition of salting out agent. So alcohol will go here and will be collected by microdrop. Then you retract this droplet back in the needle and inject it into analyzer. Just an example, we have collection of alcohols, and almost all of them are coming into this microdroplet with little problem, just in 1 minute. Diffusion in air is very quick. Similar procedure is standardly used for blood alcohol. That's headspace analysis of alcohol in blood. A liquid of blood, very small amount, 0.2 ml, with sodium fluoride and sodium oxalate as stabilizers. 2 milliliters of 3 molar sodium chloride to salt out, to force alcohol out of aqueous sample. And you are adding internal standard propanol, so you know how much it is added, and you can compare this peak to your alcohol peak. Then you do calibration with different amounts as usual, and you analyze your sample. This is a standard procedure for blood and alcohol test. It's an example of extraction from 40% potassium carbonate. You can see ethanol, acetone, 2 propanols, and amounts are fantastically small. It's nanograms per milliliter. That's how Danone yogurt will show for ethanol sky-high peak and for grape juice. So very small amounts are present in the nature of samples, can be easily detected.